Welcome back to another deep dive. We are so thrilled to have you, the learner, joining us today.
Yeah, we really are. Welcome, everyone.
Whether you're folding laundry, commuting, or just taking a well-deserved break to feed your brain, you are in exactly the right place.
Definitely. And today we have a stack of source material that honestly, it challenges a lot of assumptions about who gets to build technology.
Right. We are looking at a document called Vibe Code Blockchain, Module 1.
Which, at first glance, it's a beginner's guide to building on the Stellar blockchain.
But there is a massive twist at the center of this curriculum.
There really is. It takes two incredibly complex fields, blockchain development and artificial intelligence, and combines them into a workflow that fundamentally lowers the barrier to entry for software creation.
That is the promise of today's deep dive, and I want you to really think about this premise for a second. What if you could build global, real-world financial tools?
Apps that move money across borders in seconds.
Exactly. What if you could build those without knowing how to write a single line of code?
No JavaScript, no Rust.
Just plain English. Okay, let's unpack this, because it sounds a bit like science fiction, but this curriculum proves it is happening right now.
It is. And to fully grasp what this module is teaching, we really need to focus on two distinct but deeply connected pillars today.
Right, the network and the method.
Exactly. First, we need to understand the Stellar network itself, what it is, how it operates under the hood, and why it was built in the first place.
And then the second pillar.
Second, we'll explore this new methodology called vibe coding. That's the mechanism making blockchain development accessible to someone who has, never opened a code editor in their life.
So the source starts by laying out the big picture of Stellar. It is an open source, decentralized blockchain network.
Founded back in 2014.
Right. By Jed McCaleb, who also co-founded Ripple, and Joyce Kim. And today it's maintained by a U.S.-based nonprofit called the Stellar Development Foundation, or SDF.
But the module goes out of its way to differentiate Stellar from the broader crypto space.
Yeah. How does its mission actually contrast with the blockchains we usually hear about on the news? I mean, usually it's all about trading and speculation.
Right. When most people hear the word blockchain, their minds immediately go to Bitcoin or Ethereum.
Sure.
But those networks serve very different primary purposes. Bitcoin was designed mostly to be a decentralized store of value.
Which is why you often hear it referred to as digital gold.
Exactly. And Ethereum was built to be a massive decentralized world computer focusing on highly complex general-purpose smart contracts.
Okay, so where does Stellar fit into that?
Stellar, however, was purpose-built from day one for a very specific mission, and that is financial inclusion. The entire architecture is optimized for a fast, incredibly low-cost, cross-border financial transactions.
The source mentions a scenario that I think grounds this perfectly. It talks about a Nigerian worker living in London who wants to send money back home to their family in Lagos.
It's a very common real-world use case.
And it notes that using traditional international money transfers, like the legacy banking system, it can result in losing up to 8% of the money just to transfer fees.
Which is astronomical when you really think about it.
It seems incredibly high. How does this new system actually change that reality?
It completely upends it. To understand why, you have to look at the friction in the legacy system. That Nigerian worker isn't just sending money directly. The money is hopping through multiple intermediary banks across borders.
Everyone taking a cut.
Right. Everyone takes a cut, and each operates on different business days. That process takes 3 to 5 days to clear.
Okay, and on Stellar?
If they use the Stellar network, that exact same transfer settles in 3 to 5 seconds.
Seconds, not days.
Seconds. And the cost to move that money is a tiny fraction of a single cent. It effectively removes the friction and the middlemen that penalize the people who can least afford it.
If we are talking about saving 8% on every remittance sent globally, that is a massive amount of wealth staying in the hands of everyday people.
If we connect this to the bigger picture, the scale of this problem is staggering. The data in the module points out that there are currently 1.4 billion adults globally who are considered unbanked.
Meaning they have absolutely no access to formal financial services.
Right. No checking account to store money safely, no savings, no credit. But what they do have, increasingly, is access to mobile phones.
So the phone becomes the bank.
Exactly. Stellar's infrastructure allows anyone with a smartphone to hold, send, and receive money using digital wallets, entirely bypassing the need for a traditional brick-and-mortar bank branch.
The source also highlights that Stellar isn't just resting on its 2014 infrastructure. It mentions a decentralized exchange, or DSX, built natively into the protocol.
which means you can trade assets directly on the network without a third-party broker.
It also natively supports USDC, which is a fully regulated US dollar stablecoin issued by Circle.
That's a huge piece of the puzzle for stability.
But there's one newer feature mentioned, Soroban. The module notes it was added in 2024 as a smart contract platform written in Rust that compiles to WebAssembly, or WASM.
Yes, Soroban.
That sounds incredibly technical for a beginner's module.
Yeah.
Why does a non-coder need to know about WASM?
They don't need to know how to write it, but they need to understand what it enables. WebAssembly, or WASM, is essentially a highly efficient, secure format for running code.
Boy.
Think of the core Stellar network as a very fast, very reliable bicycle. It gets you from point A to point B cheaply.
I like that.
Soroban is like adding an electric motor to that bicycle. It allows developers to add complex, programmable financial logic, like decentralized lending or automated market making, to their apps while keeping the underlying network fast and simple.
I understand the mission now. It is built for speed, inclusion, and low cost. But how does it actually work under the hood?
That's where we get into part 2 of the model.
Right, it dives into the nuts and bolts, starting with the concept of an account. To do anything on Stellar, you need an account, which consists of a key pair. You have a public key and a secret key.
A helpful way to visualize this key pair is to think of a physical mailbox on your street. Your public key is the address painted on the outside of the mailbox.
So I can share that with anyone.
You can share that address with anyone in the world so they know exactly where to send your mail, or in this case, your funds. But your secret key is the physical metal key that unlocks the box.
And the module emphasizes this in bold text. Never share your secret key.
Total control of the account is tied exclusively to that secret key. If someone else gets it, they don't just have access to your account, they own your account. They can empty it in 3 seconds, and because blockchains are decentralized, there is no customer service desk to call to reverse the transaction.
That makes the security imperative very real.
No.
Now, to even activate that account, the source says it requires a minimum balance of XLM or Lumens.
Yes, XLM.
This is Stellar's native cryptocurrency. But it seems to function differently than how people usually talk about crypto.
It does function differently. While you can trade XLM, its primary purpose in the ecosystem isn't to be a speculative investment asset.
So it's not digital gold.
No, it's utility-driven. It is the fuel that makes the entire network run. Every single account on the ledger requires a minimum balance of just 1 XLM to remain active.
And for transactions.
Furthermore, every time you make a transaction, like sending that remittance to Logos, you pay a network fee.
And the module says that fee is 0.000001 XLM. That is practically microscopic. Why even have a fee if it is that small?
It acts as a security measure against network spam.
Oh, interesting.
If transactions were completely free, a malicious actor could write a simple script to send millions of meaningless transactions a second, overwhelming the network and grinding it to a halt for everyone else.
So making it cost a fraction of a cent fixes that.
Yeah. By charging a microscopic fee, it remains incredibly cheap for genuine users making daily transfers, but it becomes economically impossible for a bad actor to afford millions of spam transactions.
That is a brilliant deterrent. You aren't just sending XLM back and forth, though. Stellar supports custom assets.
Right. Anyone can issue a token on the network.
We mentioned USDC, but you could have a Bitcoin representation, loyalty points for your local coffee shop, or an AFRI token. Here's where it gets really interesting.
It really does.
You can't just drop random tokens into someone else's wallet. The module introduces this concept called trust lines.
Trust lines represent one of Stellar's most elegant design choices, and it fundamentally changes the default state of a digital wallet.
How so?
Think about your email inbox. The default state is open. Anyone who has your email address can send you a message, which is why we constantly battle spam.
Yeah, my inbox is a nightmare.
On many other blockchains, if someone wants to send you a scam token, they can just force it into your wallet address, cluttering it with junk.
But on Stellar, the default state is closed.
Precisely. Before your account can hold any asset other than the native XLM fuel, you must explicitly establish a trust line.
Meaning I have to opt in.
You are signing a digital agreement that essentially says, I know who issued this specific asset, I trust them, and I agree to hold it.
That's smart.
If you haven't established a trust line for a token, it is physically impossible for anyone to send it to you. It is the ultimate built-in spam filter for your money.
Okay, I get the digital mechanics. We have accounts, fuel to stop spam, and trust lines to filter assets, but I'm still trying to bridge the gap to the physical world.
The physical to digital bridge is crucial.
Right. If I'm holding a physical $100 bill, how on earth does this paper become a digital token that settles in 3 seconds? The module introduces entities called anchors.
Anchors are the crucial bridge between the traditional physical banking world and the digital stellar network. They are typically trusted, regulated financial institutions.
The module uses a very helpful analogy here.
Yes, think of an anchor like the cashier at a casino.
Let's walk through that casino analogy because it really clarifies a complex process.
When you walk into a casino to play the tables, you can't place a bet using a physical $100 bill. You go to the cashier, you hand them your physical cash, and they issue you an equivalent value in casino chips.
Right.
You use those chips at the tables, and when you are done playing, you take your digital chips back to the cashier, and they hand you back physical cash. Anchors do exactly this, but on a global scale.
So if I am in New York, I hand my real-world U.S. dollars to an anchor.
They hold that money securely in a regulated bank account and issue a matching digital token, like USDC, into your Stellar wallet.
I now have the digital chips.
Exactly. You now have the digital chips. You can send that digital token to a relative in South Africa in 3 seconds.
And then what do they do with the chips?
That relative receives it, walks into an anchor in their local country, hands in the digital token, and cashes out for physical South African rand.
That is seamless.
You aren't trying to convince the whole world to abandon their local currency. You're just giving them digital chips to move that value instantly over the internet. Examples mentioned in the text include MoneyGram and a Euro anchor called Tempo.
It completely demystifies the whole ecosystem. We have this fast, inclusive network with real-world bridges.
But there is still one missing piece.
Exactly. The barrier has always been building the actual applications. If I don't know JavaScript or Rust, how do I build a remittance app? This is where the module introduces the concept of vibe coding.
Vibe coding is a relatively new term. The source notes it was coined by an AI researcher named Andrej Karpathy in 2025.
What does it mean practically?
Formally, it is a style of software development where you describe what you want to achieve in plain English, and a highly advanced AI model generates the actual syntax and code for you.
You just tell it what to do.
You fully give in to the vibes, embrace the exponential growth of AI, and mostly forget that the underlying code even exists.
The specific tool this course uses to do that is called Claude Code, made by Anthropic. Now, to be clear for the listener, this isn't a website you log into like a standard chatbot window.
No, it's a bit more integrated than that.
Claude Code actually runs directly inside your computer's terminal. When I hear terminal, I picture those black screens with green text from hacker movies.
It sounds incredibly powerful, but also a little intimidating for a non-coder.
Yeah, very intimidating.
That is pretty accurate to what it looks like, but Claude Code acts as a translator between you and that intimidating environment. It has access to your file system.
Meaning it can actually see what I'm working on.
It can read your folders, write new files, modify existing code, run terminal commands, and importantly, it maintains the context of your entire project.
That's a huge step up from copy-pasting code from a browser.
That terminal integration is what elevates it from a helpful chat assistant to an actual development partner. It executes the mechanics of programming for you.
But the module makes it clear that it does not replace the human. It simply changes the human's role into a manager. It breaks this new workflow down into a core loop. Prompt, verify, iterate.
The 3 pillars of vibe coding.
Let's walk through a scenario using this loop. Step 1 is the prompt. This is where you describe your goal. The source gives an example prompt. Write a JavaScript function using the Stellar SDK that creates a new testnet account.
A very clear instruction.
Wait, before we go further, what actually is an SDK?
SDK stands for Software Development Kit. Think of it as a digital toolbox provided by Stellar that contains all the pre-written instructions needed to interact with the blockchain.
So it's the official toolkit.
When you tell Claude to use the SDK, you are telling it to use the official, safest tools available.
So you type that prompt into the terminal, hit enter, and watch the AI generate lines of JavaScript. But that brings us to step 2, verify.
And we really need to pause here.
The module is incredibly firm on this point. This is the most critical step in the entire process, the verification imperative. Why is reading the code so important if the AI just wrote it?
Because of the irreversibility we talked about earlier, if you make a mistake on a traditional website, maybe an image doesn't load or a button doesn't click.
Annoying, but not catastrophic.
Right. But if you make a mistake on a blockchain, you could permanently send real funds to a black hole address. Or worse, expose your secret key to the public.
So you have to be vigilant.
As a Vibe coder, your job isn't writing the syntax, but you must read and understand the logic of what Claude generated.
What kind of specific security flaws are we looking for during this verify stage?
You have to look at the generated lines of code and ask, does this actually do what I described? Is the secret key being logged to the computer screen where someone looking over my shoulder could see it?
Or screen recording software?
Exactly. Does the code handle errors gracefully? Or does the app crash if a network service goes down for 2 seconds? Deep cryptography might be abstracted away, but checking the logical flow is mandatory. You must be able to explain what each section of the code is doing.
You can't just blindly trust it and hit run.
Huh?
Which leads into step 3, iterate.
Right.
Let's say you are verifying the code and you realize it doesn't handle a dropped internet connection. You don't have to rewrite the JavaScript yourself. You just talk back to the AI in the terminal.
In plain English.
You type, this looks good, but add error handling for when the network is unavailable and log the final account balance. Claude reads the file, updates the specific lines instantly, and you verify again. Prompt, verify, iterate.
What's fascinating here is how this shifts the paradigm of innovation.
In what way?
Historically, if you wanted to build on a blockchain, you needed to understand consensus mechanisms, complex transaction construction, and specific languages like Rust or Solidity.
You had to be an expert.
With vibe coding, the technical syntax is handled by the AI. If you have the logical thinking to describe your goal accurately and the discipline to verify the output rigorously, you can build.
It is incredibly empowering.
Yeah.
But I know what you might be thinking as you listen to this. Even with AI, what if I mess up? What if I deploy a flawed app and lose all my money?
The course creators anticipated that fear.
Which is why they emphasize the sandbox. You don't start building with real US dollars. You start on the testnet.
The Stellar testnet is a complete, fully functional clone of the main Stellar network. It behaves exactly the same way, but the data periodically resets and the XLM used there is entirely fake.
A completely safe environment.
It is designed specifically for developers to experiment safely. Mistakes are literally free. You can try things, break things, accidentally expose a test secret key. It doesn't matter. It's a true sandbox.
And to get that fake money to play with, the module mentions a service called FriendBot. It is an automated tool that drops 10,000 test XLM into any testnet account you create just so you have fuel to practice with.
It's very convenient.
The module also highlights visual tools to help you verify what you're building without staring at code all day. There is the Stellar Laboratory, which is a visual interface where you can generate keys and construct transactions step by step just to see how the mechanics work.
And then there is Stellar Expert, which is a block explorer.
What exactly is a block explorer?
You can think of a block explorer like a public ledger or a search engine specifically for the blockchain. Because blockchains are entirely transparent, you can copy your testnet public key, paste it into Stellar Expert, and instantly see your balance, your trust lines, and every transaction you've ever made.
That's a great way to check your work.
It's an excellent independent way to verify that the code Claude wrote actually did what it was supposed to do on the network, rather than just trusting the terminal output.
It really provides a complete toolkit for total beginners. You get the AI to write the complex syntax, the testnet to practice for free without fear of financial ruin, and the visual explorers to verify the results independently.
It brings all the pieces together beautifully.
So what does this all mean? Let's bring all of this together for you, the learner. The key takeaways from this source material are profound when you stack them up.
They really are.
We explored Stellar, a network built not for hoarding digital gold, but designed from the ground up for fast, cheap, global financial inclusion. We learned that XLM is the microscopic fuel keeping the engine running safely, trust lines keep your digital wallet closed to spam, and anchors act as the critical bridge between physical cash and digital tokens.
That's all accessible now.
Right. And now, thanks to the prompt, verify, iterate loop of vibe coding, the ability to build on this powerful system isn't locked behind a computer science degree. With tools like Claude Code, your job isn't memorizing syntax anymore. Your job is having clear goals, iterating patiently, and fiercely verifying the security of your logic.
This raises an important question, and it is something I want to leave you to ponder as we wrap up our analysis of this module.
I'd love to hear it.
We spent time discussing how traditional blockchain development had an immense technical barrier to entry. We also discussed how the legacy financial system has an immense financial barrier, leaving 1.4 billion people unbanked and relying on expensive remittance services.
Two massive barriers.
Right. If vibe coding completely removes the technical barrier to entry and the Stellar network completely removes the financial barrier to global banking, what happens to the global economy when those 1.4 billion previously unbanked people are no longer just passive users?
Let me take control.
What happens when they are the actual developers designing and deploying their own hyperlocal financial systems in plain English?
That is an incredibly powerful thought to end on. The sheer scale of innovation that could unlock globally is mind-boggling. Thank you so much for joining us on this deep dive. We hope this exploration of Vibe Code Module 1 gave you a ton of new insights and a completely different perspective on what is possible when the barriers to building technology are removed. Until next time, keep exploring, keep questioning, and above all, stay curious.